Example 3. There are two isotopes of chlorine with mass number 35 and 37 respectively. If the isotope exists in the ratio of 3:1, the lighter isotope being more abundant, what is the relative atomic mass of chlorine? Solution. Contribution of the isotope 35, whose abundance is 3, is equals to 35 times 3, which is equals to 105. Contribution by the isotope 37, whose abundance is 1, is equals to 37 times 1, which is equals to 37. Total contribution is 142. This contribution is made by 3 plus 1, which is equals to 4 atoms. The weighted, it will become equal to 142 divided by 4, which is giving us 35.5. The relative atomic mass is now 35.5. Example 4. Chlorine contains only two isotopes with mass number 35 and 37. The relative atomic mass of a given sample of chlorine is 35.5. Calculate the percentage of 35 chlorine in the sample. Solution. The difference between the mass of isotope 35 and the relative atomic mass is equal to 35.5 minus 35, which is equal to 0.5. The difference between the mass of isotope 37 and the relative atomic mass is equal to 37 minus 35.5, which equals 1.5. The ratio of the difference is equal to 0.5 is to 1.5. Sum of the ratio is equal to 0.5 plus 1.5, which will give us 2. Percentage abundance of isotope 37. The more abundance, since 35.5 is closer to 35 and 37. Then we have 1.5 divided by 2 times 100 over 1, which will give us 75%. Therefore, the percentage of 35 chlorine in the sample is 75%. Example 5. Copper with atomic number 29 has isotopes copper 63 molar mass and the Example 5. Copper with atomic number 29 has isotopes copper 63 molar mass and the 65 molar mass. Give their atomic composition. Solution. Number of proton in nucleus is equal to atomic number, which equals to 29 for each isotope. Since an atom is electrically neutral, number of proton minus number of electrons is equal to 29 for each isotope. Number of electrons is equal to mass number minus number of protons. Therefore, for 63 copper, number of neutrons is equal to 63 minus 29, which gives us 34. And for 65 copper, number of neutrons is equal to 65 minus 29, which gives us 36. Therefore, the table below now shows that the atomic composition of isotopes are isotope 63 copper, electron will be 29, the protons will be 29, and the neutron will be 34. For isotope 65 copper, the electron will be 29, the proton will be 29, while the neutron will be 36. Chapter 2. Relative atomic masses, formula mass and chemical composition. Relative atomic mass. The relative atomic mass of an element is the number which indicates how heavy an atom of that element is compared with an atom of another element. For two elements x and y, the mass of an atom of S over the mass of an atom is equal to the relative mass of atom S over the relative mass of atom Y. During the 19th century, some standards were used, including hydrogen equals to 1.00 and oxygen equals to 16.0 as a basis for comparing mass of the elements. Later, chemists agreed on a scale in which oxygen 16.8 is given a relative atomic mass of 16. Natural occurring oxygen, however, contains more amount of the heavier isotope. The two scale using 16 relative atomic mass and the mass of the neutral occurring oxygen differ slightly. This caused some confusion until 1961, when it was agreed to establish a scale in which 12 was assigned to common isotope of carbon-12. This changes the relative atomic mass of oxygen from 16.00 to 15.9994. The relative atomic mass used in the text are based on carbon-12. The relative atomic mass of elements are determined by an equipment called the mass spectrometer. The mass spectrometer measures the isotope of an element and their abundance, forms, and the relative atomic mass is calculated. Example 1. If it was found from the determination in a mass spectrum that the element neon has 3 isotopes whose mass on the carbon-12 scale are 19.99, 20.99, and 21.99 respectively. The abundance of these isotopes are 90.92%, 0.25%, and 8.83% respectively. You are asked to calculate the value for the relative atomic mass. Solution. Contribution made by isotope of mass 19.99 is equal to 19.99 times 90.92. Contribution made by isotope of mass 20.99 is equal to 20.99 times 0.25. Contribution made by isotope of mass 21.99 is equal to 21.99 times 8.83. Total contribution is equal to 19.99 times 90.92 plus 20.99 times 0.25 plus 21.99 times 8.83, which equals to 1817.9708 plus 5.2475 plus 194.1717, which will give us 2016.91. The average mass is equal to 2016.91 divided by 100, which will give us 20.1691. 1 gram atom mass (GAM) of the element differs in mass, but they all contain fixed number of atoms n. This fixed number is called the Avogadro's number and has value of 6.022 times 10 raised to the power 24. This is often an O-level work, given the value 6.0 times 10 raised to the power 23. 1 GAM of hydrogen is equal to 0.0